In this video, I will talk about a lesser-known thyroid hormone derivative called Tetrac and its potential contribution to spontaneous cancer regression. Tetrac is derived from the main thyroid hormone thyroxine, or T4, which is made in the thyroid gland and secreted into the bloodstream. Thyroxine is a precursor to several thyroid hormones, such as T3, reverse T3, and TA4, also known as Tetrac. I will set T3 and reverse T3 aside and instead focus on the relationship between the other pair of hormones, T4 and TA4. In the past, it was assumed that T4 is simply a pro-hormone for other thyroid hormones without its own biological activity. This is because T4 cannot activate nuclear thyroid hormone receptors the way T3 does. But this view has changed since its own receptor has been discovered, although not inside the cells but on the cell surface. There is a binding site for T4 on a molecule called integrin alpha V beta 3. Integrins are a family of transmembrane proteins that link the extracellular matrix to internal cytoskeleton of the cells. There are numerous types of integrins, each composed of two subunits called alpha and beta chains. As its name suggests, integrin alpha V beta 3 is composed of the alpha V chain coupled with the beta 3 chain. Integrin alpha V beta 3 primarily binds to an extracellular matrix protein called vitronectin to promote cell adhesion, but it also has a binding site for T4, hence its alternative name is thyrointegrin. Thyrointegrin has been found on the cell surface of macrophages, the cells of the innate immune system, endothelial cells, the cells lining up the blood vessels, and on cancer cells. When thyrointegrin is activated on macrophages, it increases the activity of their inflammasomes and thus increases the pro-inflammatory output of these cells. When activated on endothelial cells, it drives angiogenesis or new blood vessel formation. And when activated on cancer cells, it drives their proliferation and makes them secrete pro-inflammatory cytokines to enhance carcinogenesis. Thyrointegrin-driven inflammation, angiogenesis, and cancer cell proliferation are all conducive of cancer progression. No wonder T4, which activates thyrointegrin signaling, is now being feared to be a cancer-promoting thyroid hormone. But Mother Nature loves balance and elegance. It has created a natural antidote to T4 out of T4 itself. This antidote is Tetrac. Tetrac inhibits T4-induced activities by blocking its interaction with thyrointegrin, and by doing so, Tetrac can inhibit cancer cell proliferation and block angiogenesis, thereby disrupting cancer progression. Tetrac is produced from T4 by deamination, but the exact deaminase that converts T4 into Tetrac is still unknown. Nevertheless, we can gain a few valuable insights from some historic research on serum levels of thyroid hormones measured during critical illness and during fasting. A study from 1976, published in The Lancet, has looked at the levels of thyroid hormones in patients hospitalized with an infectious illness. Measurements were done at the onset of hospitalization and during convalescence. Tetrac levels appear to be low at the time of illness. This is important for survival because the immune system needs to mount an inflammatory response in order to overcome the infection, and high levels of Tetrac could block the contribution of macrophages to this necessary acute inflammation. In contrast, Tetrac levels increase tremendously to much higher than normal levels during convalescence. Patients in this particular study didn't have tumors when they got sick, but have you heard of miraculous cases of spontaneous tumor regression after a cancer patient contracts an infectious illness? This was well known in 1970s and 80s. A current 2021 review of spontaneous cancer regression confirms that by stating, bacterial and viral infections are especially well documented in instances of SR, spontaneous regression. Multiple mechanisms have been proposed to explain SR following an infection, such as direct oncolytic effect of some viruses and the ability of fever or hyperthermia to kill cancer stem cells. And in addition, based on our current knowledge of cancer-stimulating properties of T4 and Tetrac's antagonism of T4, it is likely that the post-infection boost in Tetrac levels during convalescence could also be a potent contributing factor behind the miracle of spontaneous cancer regression. But there is another way to boost Tetrac without needing to catch a critical illness. This other way is fasting. A study from 1980 documented that fasting increases Tetrac by twofold. It is possible that Tetrac boost contributes to cancer-preventing potential of fasting. If you watched enough videos on my channel, you probably noticed that a good number of them is about fasting. This is because I'm leading a fasting lifestyle and I'm collecting supporting science on its numerous benefits to convince myself that it's a worthwhile endeavor. And so far I'm convinced. A number of my colleagues among natural health practitioners who I knew were leading a super healthy lifestyle have succumbed to cancer. This made me realize that organic, whole foods nutrition, exercise, clean environment, and stress reduction are all necessary components of a healthy lifestyle, but they may not be sufficient to prevent cancer. I suspect that fasting is that missing ingredient that is yet to become popular in health-oriented circles. There might be psychological and psychospiritual barriers to making fasting go mainstream. When everybody chants abundance as their mantra for personal growth and development, the idea of fasting could be off-putting, as it represents self-imposed scarcity, which we are so afraid of letting back into our lives. People may also give up the idea of fasting, thinking that fasting is stressful to the body. I can assure you that fasting is no more stressful than exercise. Exercise stresses your muscles to make them stronger, whereas fasting exercises your internal organs and tissues, so to speak, to make you stronger at the cellular level. Does it mean that we can fast willy-nilly without a thoughtful plan? No. Physiologically, we are not unicellular organisms, so fasting needs to be done in a way that's compatible with the demands of our whole body. Our unique nutrigenetic requirements, the female hormonal cycle, thyroid function, adrenals, autonomic nervous system dominance, and circadian rhythms are among factors that would dictate how and when we do fasting and when we do not. There is no one-size-fits-all regimen that can be suitable for everyone. The first time I tried fasting, I couldn't do it. I wasn't ready, but I persevered and fixed the issues that stood in the way of a successful fast in order to be able to reap its benefits. I've been doing my own alternate day modified fasting regimen and occasional longer fasts for some time now and have learned from personal experience the potential pitfalls and how to avoid them, and specifically how to make fasting compatible with female physiology. If you're interested in starting your own fasting journey, please subscribe to my channel, leave a comment, and share this video. Once my channel reaches 1,000 subscribers, I will know that there is enough interest in the subject for me to do a free webinar on fasting so that you can learn from my real-life example.